All right, welcome back. In the last video, we discovered the special relationship between the sides of a 30, 60, 90 right triangle, which offered us one shortcut into not having to use trigonometry to solve um, for the sides of that triangle. There's one other shortcut that mathematicians discovered that allows us to avoid having to use trigonometry, and that applies to triangles that are we call them 30, 60, 90 triangles, and that refers to any right triangle, and again, has to be right, where one of the angles is 60 degrees and the other angle is 30 degrees. Okay? If you run into any situation with that configuration, know that you do not need any trigonometry. You can figure out what the sides are without it. However, we're going to derive that. We're going to figure out what is that relationship between the three sides. So just like we did for the 45, 45, 90, we're now going to do the same thing, but for 30, 60, 90. So let me start on this side. I'm going to call this side x. This has a length of x. I don't know what it is, but whatever value it is, it's going to take that, take that variable. So notice that I'm choosing to start on the side that is sandwiched between the 90 and the 60-degree angle. Okay, we're calling that side x, so keep that in mind. Uh, First, let's figure out, using trigonometry, what the hypotenuse would be if this side is x. So for now, I'm going to write HYP here, and we're going to figure out what is this angle if this is 60, this is 30, and this has a length of x. Okay, just as I showed in my introduction video on how to use the trig functions, step number one is to identify each of the sides relative to your angle. So I'm going to take the 60-degree angle, I'm going to identify all of the sides. Opposite of the 60 is going to be the opposite side. Okay, this is obviously hypotenuse, and then this side must be the adjacent side. All right. Step number two is decide which are the two sides in question that we care about. Clearly, we care about adjacent since we have that length. We're calling it x. And we're trying to figure out what hypotenuse is. Okay. Now I think about my trig functions and try to figure out or remember which of the trig functions uses an adjacent and a hypotenuse. And if you think that is cosine, you are correct. So let's write the trig function here real quick. We got cosine of theta, which is the angle, is equal to the adjacent length over the hypotenuse length. Okay, I'm going to go ahead and fill in the information I have. Do I have theta, the angle? I do. It's 60 degrees. So we have cosine of 60 degrees is equal to the adjacent side. In this case, I'm calling that x, over the hypotenuse. We don't have the hypotenuse. We're trying to figure it out. But for now, let me just call it HYP. All right, so just like we did before, we're going to grab our calculator. Oops, and you already saw it there, but we're going to type in cosine of 60. And it looks like the cosine of 60 is half, 0.5. So I'm going to replace this with a half and bring everything else down. Okay, next I want to solve for HYP, or hypotenuse, figure out what is the hypotenuse when this length is x. So the first thing I'm going to do is multiply both sides by the hypotenuse to cancel it out here. Okay, this cancels this, leaving just x. And on this side we have half times the hypotenuse. All right. Now next step is I need to solve for hypotenuse. This multiply by half has to go away. To cancel out a multiply by half, I multiply by its reciprocal, which is 2. So I'm going to multiply the left side by 2 and also the right side by 2. Okay? And it looks like, this side cancels, and it looks like the hypotenuse, when this side is x, is going to be 2 times x, 2x. In other words, whatever length this is, the hypotenuse is going to be double that length. Okay? You take your x and you multiply it by 2. So that is one piece of the shortcut in our example, which is excellent. Okay, so what I can do is I can go back to my diagram here, and I say if this is x, this must be 2x. All right, that's great. Next, I want to figure out, okay, if this side is x, this side is 2x, what would be this third side, which is um, the longest side, also the side that's sandwiched between the 90 and the 30. For this example, for this next derivation, I can use Pythagorean theorem because now I do have the length of 2 out of the 3 sides. Okay, so let me redraw my right triangle here. I know that this is x, this is 2x, and now I'm trying to figure out this length here, okay, which we can call b. Let's call it b. All right, Pythagorean theorem says one of the legs squared plus another one of the legs squared equals the hypotenuse squared. All right, let's fill in the info that we know. What's one of the legs? X, so that's x squared, plus, we don't have the other leg, that's what we're trying to figure out, so let's keep it a b for now. B squared equals, what is c, our hypotenuse? Looks like it's 2x. So I'm going to swap c with a 2x, and that gets squared. All right, now my goal is to solve for b, figure out what that length is if this is x and this is 2x. So first thing I'm going to do is I'm going to expand this. Remember that 2x, all of that squared is the same as 2x times 2x, which is 4x squared. So I'm going to rewrite this and get x squared plus b squared equals 4x squared. Okay. Excuse me. Next thing I want to do is, in my attempt to solve for b, get rid of the x squared. So I'm going to subtract x squared from both sides, and I get b squared equals that 4x squared minus an x squared. So far, so good. Next, I remember that an x squared just means a 1x squared, so there's kind of a hidden 1 there. So this is now saying 4x squareds minus 1x squareds. That gives me 3x squareds. And again, that's equal to b squared. And finally, last but not least, we're going to square root both sides to get b by itself. I square root this, which cancels that, to get b equals the square root of 3x squared. All right? This is technically your final answer, but we can simplify this further down. Remember your property that says that I can separate these into two separate terms. The square root of 3x squared is the same as the square root of 3 times the square root of x squared. And it turns out that, again, just like we saw in our previous derivation, these cancel, leaving b is the square root of 3 times just x. And then just for, oops, sorry, that was a little off the projector. Just for making it look aesthetically pleasing mathematically, we're going to put this in front to get that b is x times, or x squared of 3. All right, so there you have it. It looks like if our 60, let's go back up here, if our 60 side, or the side that is sandwiched by the 60 and the 90, has some value x, and again, this value can be anything, we're just representing it as an x, the hypotenuse will be double that, 2 times x, and the opposite side, as we saw down here, is that x length times the square root of 3. So x times the square root of 3. Okay, and that is the shortcut. All right. We used trigonometry and the Pythagorean theorem to derive that relationship, but now that we've derived it, we can use it without having to use those properties, and we can just multiply or divide as needed. Let me flip to the back, and we'll try a couple of examples, and I'll also recopy this just so we can take a look at it again. Okay, so again, we have our 30, 60, 90 triangle. And remember, we said whatever this side is, to get to the hypotenuse, we've got to double it. So multiply by 2. And whatever, again, whatever this side is, and we can call this kind of our start point. Okay, let's always start here. And whatever that side is, to get to this side, we multiply by the square root of 3. All right, so that's our little shortcut. Let's use a couple of examples to see how that works. So here's example number 1. And example number 1 gives us this right triangle here. And again, this is a 60 3090 or 306090, and they tell us that this side here has a length of 9, and they'd like us to figure out what the other two lengths are. Okay? Well, luckily they gave me my starting point value, which is 9. From my starting point value, to get to the hypotenuse, I see the shortcut tells me to multiply by 2. So it looks like the hypotenuse has a length of 18. All right? Now, from my start point, which is a 9, to get to this bottom side, I need to multiply by square root of 3. So this is simply 9 square root of 3. Okay, and that's it. All right? Look how quickly we did that in a matter of seconds versus having to take out our calculator and identify angles and sides and pick a trig function and go through all that mess. Okay, this is much, much easier, much quicker. All right, that's example 1. Just like we saw in the 45, 45, 90 example, this might not always be the side that you're given to start off. Sometimes you might be given this or this, and you'll just have to work backwards using this key. So let's see a second example that allows us to practice that. So here's example 2. And in example 2, again, we get a 60-90 triangle, 30-60-90 triangle. And this time, we're given that this length is square root of 6. Okay? So a couple of things are a little different here. We have a new initial value, right? They didn't give us our starting point initial value. And actually, it's also a radical, which might complicate things a little bit. But let's go step by step. Keep in mind all the things that we know, and try not to break any rules in the process. All right. I always like to take us back to our start point, which is not where we're at right now. Notice they gave us the side that is sandwiched between the 90 and the 30. It's not really our start point. Our start point is here, the side between 60 and 90. Okay, I like to write start there. So now, if I look back here, it looks like to go from this side to this side, I multiply by square root of 3. So you can imagine to go from this side to this side, we do its opposite, which is divide by square root of 3. Okay, so we're going to divide by square root of 3. All right, so what's that going to look like? I'm going to take my starting point, or my starting value, square root of 6, and I'm dividing by square root of 3. Okay? If you think this is an unacceptable final answer, you're absolutely right. We can't have a radical in the bottom. So there are a couple of things we can do. One route is to rationalize the denominator, like we learned about in the introductory video. But there's also a second property that might make it even quicker. Okay? If you remember, the division between two radicals is the same as the radical between the division. So what I can do is I can combine these into a single large radical of 6 over 3. Okay, I can do that. Now that square root of 6 over 3 becomes just the square root of 2. That's it. Okay, so it looks like our starting point is square root of 2. So we can pop that right here. Okay, a little easier than rationalizing the denominator, but if you did rationalize the denominator, you'd get to the same point. Okay, now we are back at our starting point, so we look at our key, and now to get our final side of the hypotenuse, from here we need to multiply by 2. So we take our square root of 2, multiply that by 2, and we simply get 2 square root of 2. Okay, and that is it. So it looks like in a 30-60, just to clean it up, in a 30-60 triangle, 30-60-90 triangle, where this side is square root of 6, looks like this has a length of square root of 2, and this has a length of 2 square root of 2. Okay, no trigonometry needed, no Pythagorean theorem needed. That's it. All right, thank you for watching.